So today we're going to be doing average rate of change and looking at some different functions. So here's your warm-up. Go ahead and see if you agree more with Tyler or May. Okay, so you could have said that you agree with Tyler because the temperature dropped faster between 4 and 6 p.m. If you look at the temperature between 4 and 6, it's changing 2 hours, and it changed 8 degrees. Okay, so it was 8 degrees in 2 hours. If you look at 6 to 10, which May thinks is faster, 6 to 10 is 4 hours, and it went down 9 degrees. So May's argument is that 9 degrees is a bigger drop than 8 degrees, so it changed faster from 6 to 10. But if you look closely, it only changed 9 degrees in 4 hours. And if you look from 4 to 6, it changed 8 degrees in 2 hours. So we would say that it changed 4 degrees in an hour, and 9 divided by 4 gives you 2.25 degrees in 1 hour. So you could have argued either way. We're going to use this to talk about average rate of change as we move forward. So looking at this graph, you can see we have 2 points plotted here, 4:25, and this tells us that at 4 p.m. the temperature was 25 degrees. And then 10:08 tells us that at 10 p.m. or 10 hours past noon, the temperature was 8 degrees. So how is the temperature changing between 4 and 10? Well, if you draw a line like you're used to, and we look at that, you can see that the temperature is decreasing from 4 to 10. And how much is it falling? Well, it went from 25 degrees to 8 degrees, so it changed 17 degrees. Now, we want to be able to compare these, and so how can I find the rate that it is actually changing by? So we are going to start using a formula, kind of like slope, but we're going to put it in function notation. So we're going to label the first point, point A. The second point is going to be point B. And so our function is going to be f of B minus f of A divided by B minus A. So your x value is going to be your letter. So we have A and f of A here. And then 10 is B and 8 is f of B. So it is your output. And we can just plug those values into the function. So we would have 25 would be your f of A, and A is 4. And f of B is 8. So we would plug that into the corresponding location, and then B is 10. So our equation would look like 8 minus 25 over 10 minus 4, and we would simplify from there. So 8 minus 25 would give us a negative 17 over 6. This tells us that the temperature changed 17 degrees in 6 hours. And we can simplify that by just doing the simple division. So 17 divided by 6 in your calculator gives you negative 2.8. So the average rate of change would be 2.8 degrees per hour. So looking at this scatter plot, what do you notice is different from this one and the one we were looking at before? What do you wonder? All right. So in this scatter plot, we can see a lot more points, and all of these points kind of paint a picture for us to see how the temperature behaved during the day. Does the hourly data between 4 and 10 help us better characterize how fast the temperature was falling between 4 and 10? And could we still say that it was falling at about an hour rate? So what was it falling? It was falling 2.8 degrees per hour is what we calculated before. And you can see that based on the trend line we could draw, from 4 to 10, most of the points are very close to the line. And so it does represent an accurate measurement for how the temperature was changing. But we can't just use slope because slope would mean that it was the same the entire time. And you can tell from noon, which is at 0, till about till 4, it was increasing. It wasn't decreasing in temperature. And so this is where using the average rate of change for different points on the graph, so using specific data points can help us better describe what we're looking at. Okay. This table on the next slide is a representation of the data that we just looked at on the graph. So you have H, which is the hour since noon, and T of H, which is the temperature at that specific hour. And so we're going to find the average rate of change for these intervals. The first one is between noon and 1 p.m. So we're going to be looking at noon, which on our table would be 0. So 0:18 represents our point A. And then from 1 p.m. is going to be our point B. So we are going to plug it into our formula. And your formula, I'll write it down here, is F of B minus F of A divided by B minus A. So I'm going to have 19 minus 18 divided by 1 minus 0. 19 minus 18 is 1. 1 minus 0 is 1. And so we have an increase of 1 degree per hour. Okay, go ahead and find it between noon and 4. Okay, noon and 4, we're going to be looking at the same point A, but we're going to change our point B to be 4 p.m. So here's our new point B. And you would set it up. So we would now have 25 minus 18 divided by 4 minus 0. And so 25 minus 18 is 7, and 4 minus 0 is 4. So we would simplify that. We would say that the temperature changed 7 degrees in 4 hours, or 1.75 degrees per hour. What about noon and midnight? So we would change our point B from 4 to be at midnight over here at 12. And so now we would have 7 minus 18 divided by 12 minus 0. Okay, 7 minus 18 is negative 11. And 12 divided by 0 is 12. And so it decreased 11 degrees in 12 hours. And we now know that it decreased instead of increased because our answer is negative. And that's 0.92. So it's decreasing 0.92 of a degree per hour. And so this is where we can go back and talk about Tyler and May's disagreement that they had. And we could use the average rate of change as our argument. And so earlier we said that there was a change of 8 degrees and 9 degrees in a different number of hours. What we basically did there was find the average rate of change. So from 4:25 to 6, it changed 8 degrees. And if we use the average rate of change formula, we would have had 17 minus 25 over 6 minus 4. And so 17 minus 25 would have given us a negative 8 instead of a positive 8, divided by 4, or 2. Divided by 2 equals negative 4. I just wrote the answer there, sorry. And then from 6 to 10, we would have had 8 minus 17 divided by 10 minus 6. So 8 minus 17 would have given us negative 9, and 10 minus 6 is 4. And so we would have had negative 2.25. And you could argue that the temperature was dropping faster between 4 and 6 because it changed 4 degrees per hour as opposed to 10 to 6 where it only changed 2.25 per hour. Now we have a graph of California and Texas, and it's showing us the population and how it's changing from 1900 to 2010. So we need to estimate the average rate of change in the population in each state between 1970 and 2010. Before I let you do this on your own, I want to kind of establish what the points are. So we're looking at 1970 for California and Texas. So let's do California first. In 1970, California had a population of 20 million. So our ordered pair would be 1970 and 20. In 2010, we would go up to 2010, and it would be 2010, and going over to the graph is about 37. Okay. And then Texas had a population in 1970 at about 11 million. And in 2010, it's right at 25. So use these ordered pairs to fill in the formula to find the average rate of change for California and Texas. So looking at California, we have 37 minus 20 over 2010 minus 1970. And 37 minus 20 is going to give us 17. And 2010 minus 1970 is 40. So that tells us that it increased 17 million people over 40 years, or 0.425 million each year. For Texas, you should have had 25 minus 11 over 2010 minus 1970. And so that gives you 14 over 40. So 14 million people increased in Texas over 40 years. The population did, and that is 0.35 million each year. So if we were to ask you which state grew the most in population, you would say California did. It's about a little less than a tenth more. So which state would have grown more quickly between 1900 and 2000? We could find a new average rate of change from these points, 0 and about 3 million and 0 and about 2 million for each state, and calculate a new average rate of change. But based on what we see, you know that Texas starts out with a higher population than California. And then in 2000, if we look at the slope of the line there, and then the slope of California's line at 2000, you can tell that the slope is going to be higher for California. So it's going to have a higher rate of change than Texas is just by looking at the graph. So hopefully this helps you, and on your practice problems, you're going to be finding the average rate of change from images on a graph and from a table.